Today we're going to look at the shapes of box and whisker plots. Yesterday we looked at how to create those. Now we're going to look at how we can analyze them and describe their shape. So this first example up here at the top is just a quick overview, reminder of how we make our box and whisker plot. Remember, we use a 5-number summary. You're going to have your least value, your greatest value, your median, and then your first and third quartiles to put those 5 points in your box plot. And then the other thing we have is a box plot here that shows us how the data is distributed in a box and whisker plot. So right here in the middle, that box contains about half of your data. And then you have your whiskers on either side of that, and each whisker has about 1/4 of your data. So 1/4 plus 1/2 plus 1/4, that's going to give you 1 whole, so all of your data there. So if we look at this example down here, we have a box and whisker plot that shows the body mass index, or BMI, of a 6th grade class. So we can see it goes from 17 to 28. Here's our interquartile range. So what fraction of the students have a BMI of at least 22? Well, here's my 22, so this is the 3rd quartile. So from here to here, that whisker, well, we know a whisker is about 1/4 of the data. So about 1/4 of the students have a BMI of at least 22. And then are the data more spread out below the 1st quartile or above the 3rd quartile? And explain that. So in this case, if we look at your whiskers, whichever whisker is longer is where your data is more spread out. It's got a wider range. So since this right whisker is definitely longer, that's above the 3rd quartile, so we would say the data are more spread out above the 3rd quartile because the right whisker is longer. All right, and then interquartile range, remember that's what's in this box here. We take the 3rd quartile minus the 1st. We don't actually have to find those this time because they're already here since we have the box plot. So the 3rd quartile is 22 and the 1st is 19. So if I subtract those, I get 3. So that's my IQR, or interquartile range. That tells me just the middle half of the data, how spread out that is. So to interpret that, we would write our statement. The middle half of the students' BMIs vary by no more than 3. All right, and then on the back side, we have our shapes of box and whisker plots. So just like last week, we do have 3 different shapes. We can see skewed left is when the left whisker is longer than the right whisker, and most of the data is over on the right. So kind of like last week when we looked at this, we had the tail extending out to the left, similar idea there. Skewed right is just the opposite. Your right whisker is going to be longer. So last week, we referred to that as the tail being on the right. And then symmetric, your whiskers are going to be about the same length, and the median is going to be right in the middle of your box. And last week, we referred to that as a mirror image, which still works here because you could fold that box plot in half, and everything would match up there. So we have a double box and whisker plot down here, and this represents the prices of snowboards at 2 stores. So store A, we can see here, and then store B is right underneath it. So if we were to identify the shape of each distribution, well, looking at store A, you could go ahead and list a couple things there. You could say that the whiskers are about the same length, the median's right in the middle. You could say it's a mirror image. So store A would be symmetric. Store B, you can see that the right whisker is longer than the left. So that means it's going to be skewed right. So looking at which one's more spread out, well, the IQR of each data set, they're equal. Okay, the boxes are equal. But if we look at the range, this one, it goes, store A is from $150 to $450, so it's only $300 in that range. And then store B ranges from $250 to $650, so it has a range of $400. So store B has a greater range. So that means the prices in store B are more spread out.